Let me ask you something before we begin. Have you ever wondered how humans first realized that heat could be measured? Not felt, not guessed, but measured. Long before numbers, before degrees, before Celsius or Fahrenheit, humans were already obsessed with one invisible force: temperature. They knew heat could heal. They knew it could kill. They knew it could melt metal, bake bread, or freeze crops into famine. But for thousands of years, heat remained mysterious, untouchable, unmeasurable. And this is the story of how humanity slowly, painfully, and brilliantly learned to trap heat inside glass. Long before any instrument existed, ancient civilizations relied on sensation. Hot, cold, warm, burning. That was it. Ancient Egyptians placed their hands on a patient's skin to judge fever. Greek physicians pressed wrists and foreheads. Chinese healers described illnesses using poetic metaphors: fire rising, cold invading, balance disturbed. Heat was not a number, it was a feeling, but feelings are unreliable. Two doctors could touch the same patient and disagree. One man's warm was another man's burning, and slowly, very slowly, thinkers began asking a dangerous question. What if heat could be observed without the human body? In ancient Greece, philosophers tried to explain heat logically. Aristotle believed heat was one of the fundamental qualities of matter, not measurable, but essential. To Aristotle, heat moved upward, cold moved downward. Fire was the purest form of heat. No numbers, no scales, just theory. But philosophy alone could not solve practical problems. How hot was hot enough to cure? How cold was dangerous? Medicine demanded precision, and philosophy could not provide it. During the Middle Ages, something changed. Alchemy emerged, and alchemists were obsessed with control. Control of metals, control of reactions, control of heat. They noticed something fascinating. Liquids expand when heated. Liquids contract when cooled. This simple observation would change everything. Glassmakers, distillers, and alchemists began sealing liquids inside narrow glass tubes. Not to measure heat, but to observe change. They didn't know it yet, but they were building the ancestors of thermometers. Now we arrive at a turning point. Italy, late 16th century. Galileo Galilei. Most people remember Galileo for astronomy, but his curiosity reached far beyond the stars. Galileo created something revolutionary: the thermoscope. It was not a thermometer. There were no numbers, no scale, but it showed change. A glass bulb connected to a long tube, partially filled with water. As air inside the bulb warmed, the liquid level moved. Heat was no longer invisible. It was visible. But the thermoscope had a fatal flaw. It responded not only to temperature, but to air pressure. Weather changes made readings useless. One day warm, the next day cold, not because of temperature, but because of atmospheric pressure. Still, the idea was born. Heat could move matter, and movement could be observed. The next breakthrough was sealing. By sealing the liquid from air pressure, scientists isolated temperature itself. Alcohol was used first, then mercury. Mercury was perfect: uniform expansion, clear visibility, wide temperature range. Slowly, instruments became reliable, but there was still one massive problem: no standard scale. Early thermometers were useless across borders. A thermometer in Florence meant nothing in Paris. Every craftsman used his own markings. Then came the need for fixed points. Freezing water, boiling water. Nature itself became the reference. And from this chaos, systems emerged. Daniel Gabriel Fahrenheit was obsessed with precision. He standardized mercury thermometers. He defined reference points. He turned temperature into a language everyone could speak. For the first time in history, heat became quantifiable. And then came Anders Celsius. Simple, elegant, 0 for freezing, 100 for boiling. Temperature finally made sense. Not emotionally, not subjectively, but universally. For thousands of years, heat ruled humanity silently. It decided harvests. It decided survival. It decided life and death. And then we trapped it inside glass. Measured it. Understood it. The thermometer is not just an instrument. It is proof that even the invisible can be understood if humans observe patiently enough.